What's up, math fans? Today we're going to talk about converting radians to degrees. And of course this video has a partner video converting degrees to radians. But it's basically the same thing if you understand the concept of a conversion factor. So I'm going to show you why my conversion factor is pi radians is equivalent to 180 degrees. I'll show you where that comes from. It comes from a formula that I used to be a little more popular. I don't see it much in Algebra 2 anymore, but here's the formula. Theta is equal to S over R. Theta is in radians, and S is known as arc length. What is arc length? Well, if you have measuring tape and you are going to measure the distance around part of a circle, that's your arc length. If you go around the entire circle, that's also an arc length, but that's a really special arc. That's the circumference of a circle. Circumference is the distance around a circle. So if you remember the circumference formula from a long, long time ago, circumference formula is pi times diameter. Remember this? Cherry pie is delicious from 3rd grade? Well, there's another way to write it because the diameter is the distance from one end of a circle to another end of a circle right through the center. That's basically just putting two radii together. So instead of writing d, we write 2r. 2 radii equals 1 diameter. And they write it as 2 pi r, like that. All right? Now, this formula tells us that the measure of an angle, a central angle of course, is equal to the distance or the arc length divided by the given radius of the circle. So if it happens to work out that the measure of the arc length is exactly equal to the measure of the radius, then whatever this number is divided by whatever that number is would be 1 if they were equal. So whenever that arc length is equal to the radius, then you have theta equal to 1 radian. That occurs at something very similar to this diagram here. Now, what does that mean for you? Well, let me talk about the whole circle again. The entire circle is 2 pi r. The distance around the whole circle is 2 pi r. So in that case, S, which is the arc length, is 2 pi r over r. Alright, so this worked only when S was equal to r. So basically I did r over r. That's how I got my 1. But now what happens if it's an entire circle? What would the measure of my central angle then be? Well, if it's an entire circle, you can already start planning ahead. The entire circle, the measure is going to be 360 degrees. But what is it in radians? Let's find out. My r's are going to cancel, and theta is going to equal 2 pi radians. Central angle equals 2 pi radians. So here, when the arc was equal to the radius, I had 1 radian. When the arc is the whole circle, I have 2 pi radians. But wait a minute, what's a whole circle? I just gave you a hint, it's 360 degrees. So you're saying that 2 pi radians is equivalent to 360 degrees. And that is my conversion. If I divide by 2 here, pi radians is equal to 180, right? 360 divided by 2 is 180 degrees. Once you accept this fact, this is your conversion, and it's always the conversion. So all this background information is no longer necessary. That's just the proof. So then if someone says, well, hey, what's pi over 4 radians? Can you convert that to degrees, please? Converting to degrees is simple. I just have to remember that pi is equivalent to 180 degrees. So I'm going to replace, I'm going to substitute. So instead of saying pi over 4 radians, I'm going to say 180 over 4 degrees. And then you just divide by 4, and hopefully you get 45. Check my math, please. 45 degrees. Simple as that. It's just a simple substitution and then order of operations. So 5 pi over 6 radians converts to 5 times 180 over 6 degrees. And then you get your calculator and you'll get an answer. I try to do this in my head if I can. So here's a trick. I do 6 goes into 18 3 times. So 6 goes into 180 30 times. And then that leaves me with 5 times 30. Well, 5 times 3 is 15. So that's going to give me 150. Oh no, an improper fraction with a negative, who cares? It's all the same thing. I have negative 3 times 180 over 2, and you figure that out on your own. Again, my trick would be to do 2 goes into 18 9 times, so that's a 90, and then 9 times 3 is 27, so this gives me negative 270, negative 270 degrees, which is all good. So another way of measuring angles is, instead of using degrees, is using radians. So they could still ask you questions that we've already learned, like what's the sine of pi over 2 radians? Well, oh, I have no idea what that is. I'm not used to seeing that visually, but all I have to do is convert 180 over 2 becomes 90 degrees. So this is really just saying what's the sine of 90 degrees, and that you do know. So substitute 180, convert, and you're good to go. All right. If you're curious, the sine of 90 degrees is 1. That's a table that you got to memorize. So this conversion is very helpful. Some people teach it where they ask you to multiply the given radians by this conversion by writing it as 180 over pi. I feel like that's an extra unnecessary step, but it'll be the same thing. If I did this times 180 over pi, guess what happens? The pi's cancel out, and I still get 180 over 4, which is this. So whatever works for you. All right, thanks for watching. See ya.